So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 9 of the April Daily Leetcode Challenge and we have a high level question in front of us. So let us quickly see what the question is. Yeah, we'll just increase the font size. Yeah, so it's question 1857, largest color value in a reactor graph. So first we'll understand what is the meaning of the color value, okay? First we'll understand what is the meaning of color value and then the question asks for us the ask of the question here is to find the largest of the color value in a directed graph, okay? So let us quickly understand what are the things given to us. We are given a directed graph of n colored nodes, okay? We are given a directed graph of n colored nodes and the nodes are numbered from 0 to n minus 1. The color array which you are seeing here is the color of each of the individual nodes. For example, node 0 has a color A. Okay, node 0 has a color A. Node 1 has a color B. Similarly, node 3 has a color A again. So you can see here, right? Node 3 has a color A and so on. Like it's given in that way. So node 0 and node 2 has the same color. Similarly, 0, 1, 2, 3, 4 and node 4. Okay, node 4, node 1, this is node 4, this is node 2, okay, and this is node 0. They all have the same color. You can clearly see here in the diagram, you can clearly see 0, 2, and 4 have the same color. Okay, so this B is totally different. So this node 1 has a total different color. Similarly, 0, 1, 2, 3. This node 3 also has a totally different color. You can clearly see in the diagram. Okay, same letter. So let me quickly explain the dimensions here. So see, colors always is going to be a lowercase English letter. So that means there are 26 varieties of it. So any letter means a particular color. Okay, we are not interested in what the color. We just know that it's represented by a letter. Okay, and similar edges is the edges. Okay, for example, 0, 1 is given. That means there is directed edge from 0 to 1. Okay, 0, 2 means there is a directed edge from 0 to 2. You can clearly see that in the diagram. Okay, 3, 4 means there is a directed edge from 3 to 4. Okay. So now quickly let us understand what the meaning of color value is in this. Okay, so they are clearly saying the color value of the path is the number of nodes that are colored. Just try to understand each word of it. It's not an easy thing to understand. It took time for me as well. So please read each word carefully. The color value of the path, okay, is the number of nodes that are colored, the most frequently occurring color along the path. What that means is, take a path, whichever is the most frequently colored, what is the number of that? That is going to be the color value of that path. For example, I will again repeat, take a path, take the most frequently occurring color in that path. The frequency of that color along the path is going to be the color value of that path. Okay. For example, if you take the path as 0 to 2 to 3 to 4, you can clearly see the most frequent color is the color A. Okay. We are calling it color A. Okay. We are calling it color A. And what is the frequency of it? It's 3. Okay. In the out of 4 nodes, 3 of the nodes are colored with this color A. Okay. So along this path, the color value is 3. Similarly, if you take the path 0 to 1, okay, both there's no there's nothing frequent. Okay, so either of them you can take, and the color value is 1. Okay, most frequent one is any one of them you can take, and it's 1. Okay, so finally, what we have written is we have to return the largest possible color value along any of the paths. Okay, so they've clearly mentioned return the largest color value of the valid path in the given graph, or -1 if the graph contains a cycle. See, if the graph contains a cycle, see there will be infinite paths, right? There will be infinite loop going on, right? So we cannot find a color value in such a case. That's why I've written -1. So there are so many things happening in this question. See, first we have to find if the graph has a cycle. If it is a cycle, the answer is very simple. It's going to be -1. Okay, we've written -1. If it doesn't contain a cycle, in that case, we have to traverse along all the paths, and we have to find the largest possible color value along any of the paths. Okay, largest color value for of any of the valid path in the given graph. Okay. Coming to example 2, you can clearly see there is a circle, there is a cycle involved, right? That's why answer is -1, right? So now coming to the solution part, I will explain you what is Kahn's algorithm. See, this is an algorithm which is used for doing topological setting. Okay, I will quickly explain you this algorithm because the answer is just going to be a modification of this algorithm. It's a very important algorithm for any graph question because it will help you do the topological sorting. Okay, if see this is a hard problem, I understand that, but you should be knowing what is Kahn's algorithm for topological sorting. It will make your job very easier if you are in an interview, right? So what is so I have quickly listed the algorithm here. So let us quickly go along it, then we'll go to the answer, right? So what we have to do is, see, this is all about in degree, okay? So in a topological sorting, you will always see, just note this point, see, this, I may not be able to show the example, but if you know these points and see example by yourself, you will understand. So in a see, first of all, topological sorting is possible only for a acyclic graph, okay? DAG, directed acyclic graphs, okay, DAG. Only for that topological sorting is possible, right? So So whenever there is a DAG, there will always be a node which has a in degree of 0. Similarly, there will always be a node which has a out degree of 0. So if that doesn't happen, then the DAG is not possible. Okay. So here it's all about in degrees which we are dealing. So compute in degrees, which is number of incoming edges for each of the vertex present in the DAG, and initialize the count of the initial nodes as 0. Okay. There are two things happening. One is the in degree array, which will show the number of incoming edges for each of the nodes, and where we are storing a visited a integer, we will count the number of nodes we have visited, right? Pick all the vertices within degree 0 and add them to into a queue, okay? These are the vertices which we can start our topological sort. So these are the vertices with the in degree 0, which we can use this to start our topological sort. So we are inserting them into a queue. We have to remove these vertices one by one, and we have to do some operations on it, okay? We have to remove vertices one by one, and what we have to do, increment the count of the visited node by one, because we have visited nodes, so we are incrementing its count by one. Decrease in, see, this is very very important point, decrease in degree by one of all its current neighboring nodes, okay? Because this node is removed, and so whatever edges it has, for example, node a is removed, node a has edge to node b, so you have to decrease the in degree of b because this node a is now removed. Decrease in degree by one of all the neighboring nodes, okay? If the in degree of the neighboring nodes is reduced to 0, then add them to queue as well, okay? Add them to queue as well. So please read this, pause the video and read this part. See, I have time constraints, but you can pause and read them, right? Repeat step 3 until the queue is empty, right? If, see, the queue may not become empty sometimes. If it doesn't become empty, in that case, like the topical sort is not possible, right? If the count of the visited nodes, see, here is the important part, that's why we maintain the count. If the count of the visited nodes is not equal to the number of nodes in the graph, then the topological sort is not possible, or there is a possibility of a cycle existing, okay? Whenever topological sort is not possible, then the given structure is not a diagonal, not a direct acyclic graph. Then in that case, there are cycles possible. That's why we cannot do a topological sort on it. So this algorithm helps us in two ways. First, we can find if there is a graph, sorry, if there is a cycle or not. So if there is a cycle, we have to return -1 in our given question, right? Second thing is it gives us the topological sort, okay? Topological sort is important here because we have to carry the colors, okay? We have to start somewhere and see, because it's a graph, okay? It's not a cyclic one. We at least have to start somewhere, okay? Where we start, we can follow the topological order here. That is the idea, right? Now let me quickly show you my solution. See, n is the number of nodes, okay? It's the length of the color array as well, okay? HS is like, it's a map. Here key will be the node, its value will be a list. This will have all the nodes which are neighboring to it, okay? I'll print and show as well. In degree, as I told you, it's an array of n, it's an array of size n, which will show the in degree of the each of the nodes, right? So this is just filling that array, okay? For I comma j in, see, this is the edge given to, these are the things given to us, for example, these things, okay? It's given to us. So 0 is connected to 1. So what I am doing is, as if it's not initialized, then edge of I, see, edge of I will be a list which j has one element. If it's already initialized, then just append j on it, okay? And for each of the cases, in degree of j should be initialized, incremented by 1, okay? I will quickly print and show you how it looks. So yeah, this is the in degree. You can clearly see other for 0, it is 1. For each of the other nodes, in degree is 1, okay? And this is the, for example, the node 0 is connected to node 1 and 2. Similarly, node 2 has a edge towards node 3. Node 3 has edge towards node 4, okay? Node 0 has edge towards node 1 and node 2, okay? So this was all about this data structure. Now I am starting the console algorithm. I am declaring a queue, right? Now see, this part is very very important. See, watch out notes I am making. It's for you. This, I will give you the whole solution along with the algorithm in the comments. Please go through it, okay? See, this is not something easy. You will have to spend some time in understanding why it is happening like that, okay? We have an array of size 26 for each node. See, what happens is, we know that the color can be a lowercase English letter, right? So the maximum value it can take is 0 to, so that means 26 varieties are possible, right? 26 color varieties are possible here, right? So what we are doing is, for example, I'm traveling from node 0 to node 2, okay? So what I will do is I will increment the, for example, node 0. See, node 0 is a starting node in this case, but what will happen is it will have some color, right? That color I will increment by 1. That means when I come to node 2, I will have all the maximum, like for example, whichever node is coming here, it will have the maximum color of it, right? Okay, let me first explain you the code, then I will come to example. So count, you can clearly see here, it has, please note it down. See, this is going to be the ultimate thing, okay? This is going to be the ultimate data structure which we are going to use. Please keep it handy, all the nodes here, right? So what is happening is, count, it's a two-dimensional array, it has n rows, okay, and 26 columns. Why 26? Because a particular node, see, for example, we have to keep track, right? See, for example, when we are moving in a path, we have to keep track of each of the colors, okay? That's why we are using this kind of array, okay? So yeah, what we are doing is we are going through each of the, see, integer I will print and show at last how it's working. For now, just know that, just keep in mind that it has 26 columns and n rows, okay? One row for each node and 26 columns for each node again, right? So what we are doing is, whichever node is in degree 0, that we are appending into the queue, which I've already explained in the algorithm, right? This is my going to be the count variable, node with select count, okay? And this is going to final answer which we're going to return if there is no cycle existing, right? What we're doing is, till queue is empty, I'm running this node.pop. I'm popping the leftmost node, okay? Well, this is index 0. Then I'm incrementing, this is based on algorithm, right? We are incrementing the count by 1. Next, what I'm doing is, see, whenever I'm popping a node, I will add its color to the count array, right? What will happen is, see, just bear with me. See, initially you may not be able to understand this, but when I will show you the tracing of it, you will understand. See, this is the node array, right? First here is the node which you have popped out, right? Next index means the out of 26 which color it is, okay? Which color it is. So because the colors given to us are in alphabets, we are taking it, see, because we have to give index, right, to access it, right? So what I'm doing is ordinality. Ordinality means ASCII value of it minus the ASCII value of A. So it will give me the color. It means the index of the color, okay? So that I'm incrementing the one. That means this color has been witnessed in this path, right? Fine. How this is coming this way, I will explain at last, because this is going to be the answer finally. Before that, let me explain the other part of the code, right? So just keep in mind, whenever node is popped out, okay, its own color is going to be added into the path, okay? So the path which we are taking, right? So its own color it is added into the path. We are doing incrementing its own color by 1, right? So for each, so for example, the node may have some neighbors, right? So for node in edges, that means if this node has edges, only then enter into this part. For neighbors in edges of node, that means for each of its neighbors, what we are going to do is, for k in range 26, okay, neighbor, just understand each neighbor we are going to run this, okay? So this for loop is for each neighbor. For each for loop, these things will be carried out, okay? So what are these things? Again, we are running a for loop of 26 for range 26. What we are doing is, see, this value, okay, and this value are same, okay? This value and this value are same. So what we are doing is, if for example, there is an edge between A to B, right? If A has A in its 26 colors, it has a higher value than B, then I will just take A's value and like assign it to B, right? For example, I have been following a path, then I reached A, right? See, these things very important. See, maximum frequency of each color across the paths that end with the node, okay? That end with node. For example, whenever I'm talking about A, I'm talking about neighbor of A. That means I have finished the path till A, right? I finished the path till A. So A may have, see, A's values will be based on the path, okay, end of the path, right? But B is just a node, okay? It will have only its own color, right? So what will happen is, whatever is the maximum color for the same, see, there are 26 colors, right? For each of the color we are visiting, if the value of the color is greater in A than in B, then simply assign it to B, okay? This is what we are doing. See, this, I will again repeat, this and this are going is the same, okay? This is the kth color of the neighbor. If it is higher than the kth color of the node, node is, see, node and neighbor are neighbors, okay? node has a directed edge to a neighbor. Just understand this. A is the node, B is the neighbor. Okay, because as I told you just now, this data structure shows each color across the path that ends with node A. That ends with node A. See, this point is very very important. Okay, that ends with node A. That means it's a path, right? It's not just a node A. So it will show the color here. We are decreasing in degree. So that it's based on algorithm, right? We're decreasing in degree of the neighbor by one, and if the integrity becomes zero, we are appending into the queue. Okay. So this will now coming to, yeah. So finally, what we are doing is, if the number of node is less than n, that means uh, like topological sort is not possible here. We're returning -1. Ultimately, we're returning answer if this is not the case. Because if it's a DAG, there is no cycle existing. We're returning the answer. But one thing I am yet to explain you how this answer is being calculated. Before that, I will just quickly show you the counter. So yeah, see, this is the count array. For example, for node 0, you can clearly see it has a color A. Okay, color A means the first index. Okay, this is the for node 1. Okay, for node 0, so it has one color. Okay, now I'm traversing for example this path is 0, 2, 3, and 4. Okay, so when I go to 2, 2 means this one. Okay, so 0 and 2 has the same color. So what will happen is, when I'm popping out 0, I will increment its own color. Okay, I will increment its own color. Okay, so it will be 1 now. Then I will take the maximum here. Okay, so this will become 2. So this for the second node. Okay, you can clearly see the color A is present two times in this path. That means from 0 to 2, the two times the color is coming, right? Now coming to node, see this 3 is coming, right? 3 is a different color. So when I come to this, it has a different C. That means color A is present two times, color C is present one time. Okay, this A B C, right? A B C, C is present one time, A is present two times. Now coming to node 4, you can clearly see this particular color is present three times, this color is present one time. So this is what my answer is going to be. Now I will explain how my answer is calculated. Answer is going to be the previous maximum answer or the max of count node, the node which you have popped out now, right? Node which you are popping out, it's max. That means suppose 4 is the last node which is popped out, so we will take the max along this. You can clearly see the max is going to be 3. So along this path, so the value, the color value is going to be 3. Color value means the frequency of the most occurring color. Okay, is going to be 3. Oh, so yeah, that was all for it. So yeah, friends, if you have read out, please do comment below. And as I explained, answer is going to be the max of the node which we have popped out. And for each of the, for example, I'm at node and the neighbor is my neighboring node which I have acted edge towards. What we are doing is we are taking the maximum value out of it, right? Or for each of the colors. See this for loop is running for all the 26 colors, right? So yeah, and so if you are very thorough with Kahn's algorithm, and these are the minor changes which you are making, right? For example, this counts array, okay, and this answer is your answer for these things. These are the only changes which we have to make in the algorithm, and finally we are with the answer, right? So yeah, friends, that's all for today. If you have any questions, please do comment below. I will be very happy to discuss the solution further with you. That was all for today. Thanks a lot.